Welcome to this training video, where we'll explore parameters and return values in C# for Unity, essential concepts for any beginner programmer. At its core, a function is a self-contained block of code designed to perform a specific task, making your code organized and reusable. Instead of repeating lines of code multiple times, you can encapsulate them within a function and call it whenever needed, significantly improving readability and maintainability. Let's break down the typical C# function syntax, starting with the visibility modifier, such as public or private, which controls who can access your function. Next, we have the return type, specifying the kind of value the function will send back to the caller. If no value is returned, we explicitly use the void keyword. Every function needs a descriptive name, like calculateSum, following standard naming conventions for clarity and ease of understanding. Parameters are input values the function receives, enclosed in parentheses, allowing data to be passed into the function, making it dynamic. Finally, the function body, enclosed in curly braces, contains all the executable instructions that will be processed when the function is invoked. Think of parameters as ingredients for a recipe. Just as a recipe needs specific items like flour and eggs to create a delicious dish, a function needs parameters to perform its task effectively. These variables receive values when a function is called, making your code flexible and highly reusable across different scenarios. When defining a function, you specify both the data type and a meaningful name for each parameter within the parentheses, ensuring type safety. When calling the function, you provide concrete values, known as arguments, that must match the parameter types and their defined order precisely. Here's an example. Void movePlayer logs movement details to the console, indicating the direction and speed of an action. Parameters can be categorized as input, output using the out keyword for multiple returns, or reference using the ref keyword to modify original variables. Input parameters pass values into the function for processing, while out and ref allow functions to modify variables outside their local scope, affecting the caller's data. Now, let's talk about return values. A return value is the specific result a function sends back to the caller after successfully completing its execution. Consider it like the final, perfectly cooked dish produced by a recipe. It is the tangible output of the function after all the ingredients have been processed. To return a value, you use the return keyword followed by the value or variable you wish to send back, signaling the function's completion. The type of the return value must always precisely match the return type specified in the function definition, preventing type errors. If a function doesn't return a value, its return type is void, and return can still be used to exit early from the function without sending any data. Here's an example. And addNumbers calculates and returns the sum of two integers, providing a numerical result. Now, let's see how to practically implement and utilize these fundamental concepts within the Unity editor environment. First, create a new C# script in your Unity project, perhaps named Function Example, to logically house our custom functions. Open this newly created script in Visual Studio and define your functions with parameters and return values, exactly as we discussed earlier. For instance, addNumbers takes two integers and returns their sum, while moveObject takes a gameObject and a distance to translate it in the scene. Next, create another script, like ExampleCaller, which will be responsible for invoking these functions. In ExampleCaller, declare public variables to easily reference your function example script and a target gameObject from the Unity inspector. Drag and drop the function example script and a gameObject from your scene onto these public fields in the inspector to establish connections. Within the start method of ExampleCaller, call addNumbers with specific arguments and store its returned integer value in a variable. Then use debug log to display the calculated sum clearly in the Unity console, verifying the function's output. Also, call moveObject, passing your target gameObject in a specific distance to visually observe it translate within the game world. Run your Unity scene. You'll immediately observe the sum printed in the console and the gameObject visibly moving forward as expected. For best practices, always use descriptive and meaningful names for functions and parameters to significantly enhance code readability and understanding. Ensure each function has a single, well-defined purpose, strictly adhering to the single responsibility principle for cleaner code. Add clear and concise comments to explain complex logic, and thoroughly test your functions with various inputs to ensure correctness and reliability. Avoid common mistakes like mismatched argument types, which lead to compilation errors, or missing return statements for non-void functions. Always pass arguments in the correct order as precisely defined by the function's parameters to prevent unexpected behavior. Mastering parameters and return values is a fundamental skill, crucial for writing modular, reusable, and maintainable code in Unity with C#. This foundational knowledge will empower you to build more complex and interactive games, opening up endless possibilities. Keep practicing and experimenting,